So at this point, you should know how to find the relative extrema or the minimum or maximum points on a function using the first derivative in a sign diagram. But the second derivative test allows you to simplify this step a little in some cases, where if you have your x values, then you can plug them into your second derivative to find out if they are minimum or maximum instead of using a sign diagram. So for example, if your point is a minimum, like on this parabola, then the second derivative, when you plug in your x value, would be greater than 0 because the slope is going from negative to being positive, which means that your first derivative is increasing, so second derivative will be greater than 0. And same logic, if your point is a maximum, like this one on the parabola, then your second derivative will be less than 0 because the slope is going from being from being positive to being negative, which means that it's decreasing, so second derivative will be less than 0 when you plug in that x value. Now let's try this test on this function. Let's find the relative minimum and maximum using the second derivative test. So first we find f prime of x, which is equal to 6x squared plus 6x. And when we set this equal to 0, we get 6 times x squared plus x equals 0, or x squared plus x equals 0, or x times x plus 1 equals 0. And well, you could have factored out the 6x with each other, but now you get x equals 0 or negative 1. And now we have our values, but we don't know which one of these are minimum or maximum. So let's find our second derivative, f double prime of x, which is equal to 12x plus 6. And when we do f double prime of 0, we get 12 times 0 plus 6, which is positive, meaning that at 0 there is a minimum. And let's try negative 1 now. So 12 times negative 1 plus 6 is negative, meaning that there is a maximum at negative 1. So we just easily used our second derivative to find that at 0 there is a minimum, and at 1 there is a maximum. Now let's do another example. Let's say we have this function x cubed minus 6x squared plus 9x plus 1, and we want to find the relative extrema of this function. So as always, first we find f prime of x, and we get 3x squared minus 12x plus 9, and then we set this equal to 0, and we can factor out a 3 from all of this, so we get x squared minus 4x plus 3 equals 0, and then we just factor it, x minus 3, x minus 1 equals 0, so x equals 3 or 1. And then now, instead of drawing a sign diagram for this, we're going to try to find the second derivative. So f prime of x is equal to 6x minus 12. And we just plug in the 3 and 1. And so for f double prime of 3, we get 6 times 3, 18 minus 12 is 6, which is more than 0, which means that at 3, it is a minimum. And then let's try this f double prime of 1. We get 6x minus 12, 6 times 1 minus 12. And this is going to be negative, which means that at 1, it is a maximum. So using the second derivative, we figured out that at x equals 3, there is a relative minimum, and at x equals 1, there is a relative maximum. Now, let's do a practice problem. If you think you know how to do this one, pause the video and try it. This one says, find the relative extrema of f of x equals sine x such that x exists in the domain 0, 2 pi. So as always, the first thing you need to do is find f prime of x, or the first derivative. In this case, it's cosine of x, and set it equal to 0. And just by knowing the unit circle, you can know that x is equal to pi over 2, or 3 pi over 2. And now we have our x values, but we need to find if they are minimum or maximum. So let's find f double prime of x, which is just negative sine x, and plug in pi over 2 and 3 pi over 2 into this. So f double prime of pi over 2 is going to be negative sine pi over 2, which is negative of 1, which is negative, which means that at pi over 2, there's going to be a maximum. And let's try 3 pi over 2. F double prime of 3 pi over 2, which is equal to negative sine 3 pi over 2, or negative of negative 1, which is just 1, which is positive, meaning that at 3 pi over 2, there is a minimum. So using the second derivative, we found that at pi over 2, there's going to be a relative maximum, and at 3 pi over 2, there's going to be a relative minimum in the function sine x. So everything that I just explained and all the problems that I went through should teach you everything you need to know about finding relative extrema using the second derivative or the second derivative test. And just keep a note that just because you know how to do this doesn't mean you should. In a lot of cases, drawing a sine diagram is going to be easier if finding the second derivative is going to be challenging. But if you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.